All right, welcome in everyone. Thanks for joining. We are back on LeetCode. So this is day 2 of being laid off as a senior software engineer. This morning we went to the gym. We had hibiscus lemonade, try to improve mood, right? Get in the right mindset and get ready to get back to the old familiar grind of LeetCode. So here we are, leetcode.com. Signed in with my GitHub. I checked the points because it makes me remember if I'm in my right account, because there's different ways to log in, right? With Google, with GitHub. And so I see my older history. So it's like, okay, this is the right account. And I went for premium. Anytime that I'm seriously on the job search, I'm going for premium. I know it can hurt to spend money when you just lost your job. This is when you break out the credit card. Like, as a PhD in economics, this is like the one time you're allowed to break it out if you need to. Fortunately, I don't need to, but I paid for premium over here. And then I have the Latterly blog pulled up. We're going to use the Latterly LeetCode kata. No need to reinvent the wheel. There are proven methods, evidence-based methods on how to approach LeetCode. Don't get lost in the sauce. I don't know where to start. LeetCode, Blind 75, all these different approaches, Sean Prasad's patterns. You just go here. This is better than all of them. I dare someone to do a better protocol than this. I contributed to Sean Prasad's patterns, and I created the 5 to 23 patterns article, which goes even beyond his 14 patterns. Okay. So this is an evidence-based LeetCode approach, so we know exactly where we're going. We got the account set up, and let's dive in. So what's step 1? Twosome, good old twosome. Twosome 2, the form with the arrays sorted, number 167. So we'll be diving into this. And since this is my first day back on LeetCode, I don't need to go all the way through the kata, right? If I'm in your shoes, even doing one problem is a fantastic step in the right direction. What you want to do is build the habit of the job search. The job search is its own habit, its own protocol. I wrote up my protocol on the wall back there. You can see my TikTok or YouTube video where I go over it. But basically, it's like a couple days of LeetCode, or a couple hours of LeetCode, an hour of actually applying to jobs, an hour of content creation. I make sure to do an hour of recreational code, and those are the ratios. And then you can scale those up or down depending on like how much energy you have that day. So you don't need to go all out every day, right? You can scale up and down. And I do encourage you to take at least a day off a week, probably take off 2 days a week, treat it as you would a job. So the job search is your job. And I think it's really important, if possible, the day that you're fired, the day that you're laid off, the day that you're engaging the job search, start LeetCode the first or second day. Start the job search activities the first day. You don't need to go to 100%, but start doing some of them so that you're building that habit. So I actually applied to 2 jobs yesterday, and I reached out and I did some direct messages, just sitting on my couch from my phone, and I was able to get a referral, day 1, before, like the day of my layoff notice. Okay, so I think that gives you the background. We're not going to necessarily go crazy today. We might do 1, 2, 3 problems today. And follow the channel if you want to see me go all the way through the kata. So the basic kata is 12 problems, and the expanded kata is 20 something, straight up 20. The expanded kata is 20. So follow the channel if you want to see me go all the way through, binary tree and word search, all that fun stuff, path sum. Today we'll be doing 1, 2, probably 1 or 2. If I'm really feeling it, maybe I'll go for longest substring. I'm in my senior year of CS and I'm scared. Don't be. Join the Discord. So here on the Latterly website, if you scroll to the top, there's a community tab and there's a Discord, and you can join it. Some of the behaviors that I do as a senior will be slightly different, but a lot of them won't be different. The main thing that I'll be doing differently is, as a senior, I have the luxury of being much more selective of the companies to which I apply. So I'm targeting a FANG tier 1 role, which means as a junior, as a CS, a senior CS, I would be encouraging you to apply to 80 companies per week, including tier 2 and tier 3 companies. I'm going to be doing like 20, 30, 40, 20, 30, 40 a week. And then I might up that if I need to. Really, I won't up that. But I might change my tier. So I have a couple months to do this based on like my financial situation. I have a couple of months of breathing room. And so in month 2, I expect to be in Fang loops. But if I'm not in Fang loops, that's when I'll go, okay, well, let me look at tier 2, tier 3, and kind of a fallback plan kind of approach. Does that make sense? I suspect that I won't need to up my volume at that time because I have contacts. I have contacts at these companies. But if I didn't have contacts, yeah, I might up my volume at that time. But in the beginning, I'm going to be somewhat selective. I want to be investing a bunch of time into interview prep and not as much time into doing tier 2 and tier 3 interviews. Like I want to really make sure I can knock out these tier 1 interviews when I get one. So that's a slight difference between the senior and the junior level. But I would point you to the LeetCode kata, and basically I would have you doing the same things, except I would have you at a much larger volume and not specifically targeting tier 1. So let's clear this out before I read it. Maybe I can leave the comment. I'll leave the comment. Let me review the comment. It's going to include the time complexity. I'm kind of cheating, whatever. Okay. Next time around, I'll wipe the comment too, but this is going to be good for jogging my memory. So we start by just reading it. Given a one-indexed array, one indexed is important, of integers called numbers. Here we're in Python, by the way. What do you think about doing interviews with tier 2 to 3 interviews? Sorry, I read your question wrong. What do you think about doing interviews with tier 2 to 3 interviews? Oh no, that is what you wrote. Tier 2 to 3 interviews. I thought you meant tier 2 to 3 companies. I guess you're using the word interchangeably there. To practice first. Yeah, basically the answer is yes, and this is exactly what I'm doing. So the 2 companies that I applied to yesterday, one was Netflix, and that was probably a mistake. The first place that you apply should not be Netflix. So I'm not counting on getting that one. But the second place that I applied, I would call a tier 2 company. They're a tier 2 company that's paying quite well. So that's why, and it's remote work. So that's why it was acceptable to me. And it's in an industry that I care about. So those are some of the reasons that I thought it was interesting, even though it's tier 2. But your general strategy of using warm-up interviews first and then going for the hard ones a bit later is absolutely the right thing to do. What's a tier 2 company? How do you define the tiers? So this is how I look at it. Tier 1 is Fang and Fang adjacent. What does Fang adjacent mean? It means that your compensation structures are similar to Fang. So Meta, for example, at E6, a staff role, they will be paying $800K total comp, which is insane money to most companies. But Fang and Fang adjacent companies routinely pay this amount. And then also the skill expectations, the skill matrices are similar. The interview styles are similar. So they're going to have coding rounds, behavioral, sys design. You're going to be graded in a relatively consistent way. These are the attributes of Fang and Fang adjacent companies. And these are tier 1 companies, also called big tech or big N. So back in the day, it was Fang. Now Fang is kind of dated, but it's basically like the same idea. You're elites. And also there's just large headcount at these companies. So if your company has 500 employees, it's probably not big tech, right? Okay, so that's what tier 1 means. What does tier 2 mean? When I say tier 2, I mean a household name. A household name that's not tier 1. So a household name might be like the large banks, Bank of America, Chase. These are household names. It could be like Walmart. It could be, I don't know, Barnes and Noble. Like, what's a household name? You know? Yeah, you're sort of like large grocery stores. Clorox maybe is coming to mind for some reason. I guess I need to clean my house. Look at that wall. I probably need to clean that wall. So a tier 2 would be a household name. And then tier 3 is like a no-name company. So like no one's heard of it. there is this weird edge case of startups where it's very common to have a startup that no one's heard of and it's quite small, but the quality bar for tech is still high, especially if it's like a Y Combinator or an Angels List startup. So startups kind of get their own category, and arguably you can be a no-name startup but still be like comparable to tier 2. Or you could even be trying to clone the FANG skill bar. This is less common right now because the economy's down, but when there's more investor money, even startups can afford to pay those FANG salaries, believe it or not. So for our purposes, when we talk about tier 1, we are going to be mainly talking about the interview loop, because these companies are all doing LeetCode, basically. It's possible to do hiring without whiteboards. So make note of this. If you have trouble with LeetCode, one approach is to get good. That's what I'll be doing today. Another approach is hiring without whiteboards and just avoid LeetCode entirely. So here's a list on GitHub. Many of these will not be these are not tier 1 companies, basically. So Accenture is not a tier 1 company. Maybe it's tier 2, pretty big name, right? Other of these names, I don't even know what they are. Maybe I'm just ignorant. I don't know what Abstract is. Airtable would be, I think, pretty well-known name. So there are some cool companies. You can get 6 figures without doing LeetCode. It's true. So Blue Bottle Coffee, thank God for Blue Bottle Coffee. Am I right? I mean, shout out to those people. Thanks for the follow. Thanks for being here. By the way, if you're on TikTok, tap the screen to give it a like so that the algorithm will send it around so that we can educate more people. And also, link is in my bio if you want to visit YouTube, and you'll be able to see the full screen. Thanks so much. Okay, so this has been wonderful background. I'll take one more question, and then we actually need to code. One more question. Any free programs or courses you recommend to start learning? Yeah, go to ladderly.io. Link is in the bio. So that's the social account that you're looking at. You can start with a free account. You can unlock things with as little as $1 a month. And you get a step-by-step checklist. You get a step-by-step checklist. Now, the truth is that a lot of free programs are just not good enough to get you a statistically significant hireability effect. So, you can do like Free Code Camp. I love them as an organization, but I haven't seen any statistical information that a Free Code Camp certification is significantly associated with job hireability is the word, or like job attainment, or job search speed or quality. Thanks again for the follow. Any tips for someone just starting a coding course online? What can I do to get my foot in the door? You need to connect with a social network. Social network, social network, social network. Come over to Ladderly, check out the Discord. I'm not saying Ladderly is the only social network you should join. There's going to be a bunch of others. You can check out the networking scripts. Oh, sorry. Those will be helpful, but those will be helpful for social networking, like interpersonal communication. For community networking, there's the endorsed communities. So there's a bunch of really great communities you should join. Ladderly is just one of them. I should update that. It's well more than 100 now. But the reason I say, hey, go to Ladderly is because I can talk to you after the stream and give you like a whole lot more detail. So for now, head over to Ladderly, sign up, make a free account, join the Discord. And no, I'm not saying Ladderly will solve all your problems, but I am saying let's get into coding, and feel free to come over to the Discord and ask a whole bunch of questions later. I've been using NeetCode lately. I like it better than Algo Expert. I agree with that, but the LeetCode kata is better than NeetCode. It's better than NeetCode. It's better than the Blind 75. It's better than Sean Prashad's patterns. Like, y'all need to go read this. I don't think you understand how good this is. Literally. And I love NeetCode. It's no shade. The guy is awesome. The website's awesome, but it's old at this point, dude. Like, it's been around for years, right? Like, it's not the latest evidence-based approach. Thanks so much for this. You're welcome. Okay, so anyway, let's get into it. You can do all like the, oh, look at these fancy lists, but it's just two-sum. Let's just do two-sum, shall we? Okay. Good to see y'all here. Thank you for the follow. Okay, so we have a one indexed array of integers. It's in the variable called numbers. It's sorted in non-decreasing order. Because it's sorted, y'all, this should if you're new, this might not happen, but once you're experienced, the fact that you know that it's sorted immediately should say like either 2 pointers or sliding window or some bounded array solution, like a set-based solution. And I'm pleased to say it's jogging my memory, even though I haven't done LeetCode in a while. Sorted in non-decreasing order. Oh, okay. Pointers. Marco says, I'll be finishing up a coding boot camps in a few months. What type of company should I be aiming for? I learned MERN stack. Mongo, I don't encourage Mongo. You should learn SQL. But I mean, that's fine. Like, I don't think you should be going to companies like, hey, I know the MERN stack. That's not going to like attract a lot of companies. Some companies will be impressed with the particular keyword React, but the rest of the MERN stack, I don't think people really care. What I would say is that after you graduate from your boot camp, hopefully they've incorporated some data structure and algorithms, some LeetCode, what we're doing right now, some whiteboard interview preparation. Unfortunately, it is all too common that bootcamp career services don't fill the gap, and even college career services don't fill the gap. That is the reason I created Latterly. Latterly is not a bootcamp. It is a bootcamp supplement and a college supplement. So come over to the Discord, man, and I'll give you all the details. But if you want to use the keyword React, you can target tier 3 and some tier 2 companies directly using your portfolio, using the keyword React and saying, hey, I know React. Even if I don't know LeetCode, I know React and I have a portfolio, and you can still get a job. I wouldn't be expecting a 6-figure job, but you can still get a job. If you want to up your game from that, it's quite simple. You just need to prepare for the standard FANG loop, which is LeetCode, behavioral, and maybe or maybe not sysdesign. At the junior level, you really don't need sysdesign. Is Latterly free? Yeah, you can sign up for free and you can unlock additional things for $1 a month. There's a premium tier with not in person, on Zoom, but like live courses, basically, a weekly small group. And you can do that starting for $30 a month. That's a limited time only. That's going to be going up soon. I might do one more cohort at $30 a month, and then it's going to go up. But you can sign up for free, and you can get a whole bunch of stuff. Can I get a job knowing only Python? Yes, it is possible. Possible and optimal are not the same. Programmers, for whatever reason, I noticed this correlate, that programmers don't tend to think in terms of probabilistic reasoning. They like to think in terms of like one-to-one deterministic reasoning and like, is it possible or impossible kind of thing. I want you to update your mindset and think in terms of optimal is a probability-based concept. It's not a deterministic. It's not a deterministic problem. So yes, it is possible to get a job knowing only Python, but I wouldn't encourage that approach. It's really easy to pick up a bunch of other keywords that are going to boost your job search performance without much effort. That's a great investment, great ROI, very optimal. Is not having a CS degree a detriment? At the junior level, absolutely it's a detriment. But again, detriment doesn't mean impossible. It just means it's going to be harder for you. Yeah, not having a degree is definitely a detriment. What does Latterly do that increases the odds of employment? Yeah, go through the checklist. I'm going to try to get back to coding here, but one thing, I mean, here are 26 things it does for the free tier, and then it's even more if you start paying. I'll give you an example of one of the paid ones. Is it gives you tips like go use LinkedIn Premium. Here's the advanced checklist. You can take a sneak peek. Go use LinkedIn Premium. It's evidence-based and improves your job search. What evidence is there that we should use LinkedIn Premium? It's on the page here. Let's see. Looks like they changed yeah, there you go. They changed the layout of the page. 4.6 times more effective than email alone is using the LinkedIn Premium in-mails, they call them. So you've heard the saying, death by 1,000 cuts. Latterly is like the opposite of that. It's like success by 1,000 tips. And so this is like one concrete example that you can see on the premium tier where it's like, whoa, that's an evidence-based practice that will improve my job search outcomes. When I'm reaching out to people, I want to convert that to an interview and then succeed in the interview and then get an offer and negotiate an offer. Those are your stages, right? At every stage, Latterly has some tips. Okay, all right, let's get into code. Thanks for all the questions, everyone. I see questions are still coming in. At this point, unfortunately, I'm going to have to cut them off. Sign up to the Discord, latterly.io, and bring your questions over there. But the main purpose of today's stream is to do some LeetCode. So let's go do some LeetCode. All right, so I have some indexed array of numbers sorted in non-decreasing order. So it could be like 0, 0, 1, 1, like you can repeat, but it will never be decreasing. And then the other thing that's important to remember that is kind of a gotcha with toSum is the return format. Do you want to return the values or the indices? And then if you return the indices, like how do you return them? As a set, as a list, as a tuple? So we can see that we want to return the indices of the two numbers added by 1 because it's 1 indexed as an integer array, index 1, index 2 of length 2. Great, so I think we know the basics. So given that, and then I'll read through this comment, but really I shouldn't even need to read through this comment. We can know that I'm going to be using either pointers or a sliding window. It's going to be a bounded set approach on the array. And why would that be? So we're trying to get this target, right? Let's say the target is 5. Whatever, and then I have a pair. If I start down at the bottom, I have like 0 and 0, and then I just keep moving 1. I could go all the way to the end, and I could maybe never hit my target, right? So what if I go all the way to the end with my right side pointer? Well, then I need to move my left side pointer too. So I potentially need to manipulate 2 pointers. So that's why a base case is like 2 pointers. You could start with them both on the left and then move 1 and then lazily move the other if needed. It's kind of, yeah, you could do that. Maybe it just makes the code nicer that you start by pointing at either end. There's this while condition you'll see where when they cross each other, that's an exit condition. So I think it just kind of makes the code nicer. Does it limit? Is it a limiting case of any reason? I mean, it's kind of a limiting case because you get the min and max value, but I don't know how relevant that is. I think it probably just makes the code nicer is why we start on both ends. It does linearly or like by a constant factor speed up because you don't need to go over and then, right? You just start on both ends. That won't change the asymptotic performance actually though. So I don't know that that's a strong reason. The thing is just that it makes the code nicer. Or that on LeetCode, they want to squeak out those extra milliseconds. So even if it's not an asymptotic difference, it will save you some milliseconds. And they care about the leaderboards. That's probably true, right? So even the Amazon coding interview or like coding screen does have performance limitation and it will time you out. So that even if your solution is asymptotically correct, you need to do better than that. It needs to pass a fixed gate performance threshold. So I think that's right. You'll start at either end. It does make the code nicer, but then also it does give you a non-asymptotic speed up, but we still care about that speed up. I think that's right. Okay, great. Let's go ahead. A valid result is guaranteed. No need. Oh, who put that extra E there? Given this, use 2 pointers allowing worst case time complexity of O of n, because I might need to scan all of the pairs. Not all the combinations. Not all the combinations. I'll manipulate 1 pointer at a time. I might need to look at all of the numbers. And then about memory, it's constant. There's only constant overhead, some pointers. Okay. So we'll do result is going to be this, and then we'll eventually return result. numbers is already sorted. I'll do left equals 0, right equals length of numbers. Okay. And then I like to use this while loop syntax, while left is less than right. And this is just like a really clean way to write the code. You could do this other ways. Part of it is that we're in Python is part of the reason it looks nice. Like if you're in a different language, it might not look as pretty. But I just think it's really readable. So whenever those hands cross, you're doing something wrong in 2 pointers, basically. Or it's an exit condition. If you're doing it right, it would be an exit condition. If you're doing it wrong, you might cross without a proper exit condition. I'm so glad I'm doing this practice because the way I just explained that would not fly in an interview. I did such a bad job right there. Okay, let me try to state more eloquently why we want to do while left and right. The reason that we want to do while left and right is quite simple. If I want to increase the value of the sum of left and right, I need to move my right pointer further to the right. This is one of the reasons that it's interesting to start my right pointer all the way to the right so that I actually never have to do that. So that if I need to move my right pointer to the right, I basically just know that I need to exit because like I can't do that because I've already checked all the way to the right. So you want to decrease it and decrease it and decrease it. And if you want to increase your sum, you move your left pointer up. Okay. Yeah, and that's how you can either get the minimum amount of the range sum, the maximum amount of the range sum, or you can converge on the proper index combination to get your target. But if you go all the way to where the hands are together and you haven't found your target, you should go ahead and exit because the target just isn't computable. You don't have the values available to make that target. Okay. I think that was good enough. I need to explain that better, but I think I explained that well enough. So you have your 2 pointers, you're coming to the middle, and if you don't have it by then, it's time to say, I just don't have it. Except that in this version of the problem, we're guaranteed to get it. So we'll always get it. There's probably a more intuitive way to explain that. I'll think about that. Yeah, in my mind, it's just like, have you ever seen like Indiana Jones with the walls closing in? You put something there and you're going to squish it. Like you're eventually going to squish it. That's what these are doing. They're converging on the array sum. Okay. So here is the current sum. Current sum is left plus numbers right. This should be numbers left, not just left. Okay, so there's the current sum. If the current sum is under the target, we want to increase current sum by moving left hand up. Okay. Else if else. Found a match, return. And to return, I can just say break. I could just break. I'll just break. That'll save us some time. Break to save time, then return. No, breaking won't save time compared to returning immediately. Let's just go ahead and return. This will be our sad case that we should never hit. Make sure my indentation is correct. I think so. So when we find the match, we'll return left plus 1, right plus 1. Okay, and in this case, if we're over. So if the current sum is over the target, then we want to decrease the current sum. And the way we decrease the current sum is that we move the right hand to the left. Right, so the way to move the right hand to the left is just like that. Or let's see, maybe minus equals 1 is a little better. Okay, let's see if that solved two sum. Whew, I feel super rusty. Return is used outside of a function. I need to indent once. Was that it? Python and your indentation. It'll never be good to me. Okay. The length of numbers, let's say I have 3 numbers, then the far right index is 2. So I need to do length of numbers minus 1. Okay, cool. I think we solved two sum. Can I have 6-figure job now? Thanks. The hilarious part is like some places that would get you a 6-figure job. Let's do one more. And then we spent a bunch of time on other stuff. So I think we'll only do 2 today. But follow the page. I might do another LeetCode round later today. Because like that was a super easy problem. But I also have a bunch of energy. So I might do another round later today. I may or may not stream it. But then I'll definitely be doing a round tomorrow. Okay, 3 sum. This is more fun. And then there's variations of 3 sum. Get rid of all these comments. Oh, by the way, laterally does have some solutions. So if you're like, man, I can't find the solutions. Okay, there's a whopping solution to the first 2. Sorry. Feel free to contribute your solution on GitHub. And a lot of these problems will have solutions anyway. You can come over here to the solutions tab, but sometimes there's like not a very clear or good solution, or I think I can communicate a solution more eloquently. Not so much today, but there have been glimmers in the past. And in those cases, I wrote down some solutions. So there you go. 7 is the counterpart to 3. That's another, someone was asking earlier, like, what does laterally do to help you? That's another thing it helps you do, is it'll give you some of the solutions to these problems. There you go. So with 3 sum, we have an integer array of numbers, return all the triplets such that we're not returning the same indices, and the sum of the triplets is 0. Okay. Some things that we're noticing here. It doesn't say that it's sorted. Let me go ahead and write down the notes. It doesn't say that it's sorted. So we may sort O n log n. So if we sort, it'll be using O n log n. If we choose to do that, how do we choose to do that? The answer is if our performance asymptotic boundary is equal to or larger than O n log n, then we will sort because there won't be a penalty. But if we can come up with a different solution that is performance O of n, then sorting would be a bad idea because it will create a slower boundary. And we don't want to introduce lag. We don't want to make ourselves slower, right? Okay. So that's one thing to note. The other thing to note, yeah, pretty much that's the main thing. We can get negative numbers. That's fine. That actually doesn't impact anything. And then what are we returning? We are returning the values, not the indices. Notice that? So it wants to give you the ith index of nums, I of nums. So I of nums is not I, where I is the index value. So we don't return the index values, we return the array values, or the elements of the array. Pretty much that's it. Okay. Approach. Wrap TwoSum in an O of n wrapper for overall O n squared performance. Is there a faster way to do this? What about no sort? How fast is no sort? How fast is no sort? So if I do no sort, I'm scanning through the object and I'm collecting the differences, and then I will look for, given those differences, I will look for a value that adds to the difference to make 0, the complement. I'll be searching for the complement. Yeah, I don't know. I can't remember. Is no sort faster? It's at least O of n. Is it O of n squared? Seems like it's O of n. Seems like you would scan through, and you might have to scan through twice, but even if it's 2 passes, it would still be O of n. Okay, so I'm going to say that no sort is O of n. I might be wrong about that. Obviously, you're building up memory overhead. So you still end up with total complexity of O of n squared, but it is faster. You end up with total complexity O of n squared, but it's faster. The TwoSum wrapper approach would be no mem. No memory complexity, but it would be slower. It would be slower. So which do we prefer? We usually go for like speed due to user experience, unless there is a constraint on memory for cost reasons or whatever reasons, and then we would reduce memory. Let's prioritize speed for UX. Unless there is a mem cost constraint. Okay, so in theory, I should be doing no sort right now. The problem is I don't entirely remember how to do no sort. It would be a lot easier for me to go, oh, sort it, and then I have my TwoSum that I just did, and then we'll do a wrapper around that. That would be easy. Good. It's good that it's not easy. Okay, so I will want to do, so let's go from no sort. Okay, so how to do this? So I want to build up a cache. I will call this scene. When we see, so what is scene? It's basically a cache. So when we see a complement, what I need to do is I need to track the indices and their complement. The reason I need to track the indices is so that I can ensure that I don't return duplicate, because you see it's a problem requirement that I is not J is not K. Imagine a situation where I have a 0, 1, 2 is my whole array, and the target is 0. Well, what I might end up doing if I wasn't careful is I might end up returning 3 zeros, but they're all I equals 0. So they would be duplicate on the index. Okay. Doing 2 problems today feels good because I feel my brain draining now. So I think we've right-sized it. But this is the abstract data that I need to capture. I need to track the indices and their complement. So the key value arrangement, the intuitive thing to do would be have the complement as the key, because it's an integer key, which is like relatively intuitive. Technically, though, it doesn't have to be that way. Technically, I could do a tuple key. I could do a tuple key. I just don't want to. So I will track complement as key and tuple indices as value. Okay. So what's my while loop here? We talked about the possibility that I might need to scan through the array in 2 pass. So if I need to scan through the array in 2 pass, I cannot do I can't return the sad case. So sad case is going to be returned. So this is our sad case when no triplets are found that sum to the target. So again, imagine the 0, 1, 2 array and then target of 9. There's just no triplets that are going to do it, right? This is another difference between the two sum with the array input sorted. What I would like to do is do a 1 pass and then otherwise return the sad case. But if a 2 pass is possible, I can't do that. So I want to drill down and see whether the 1 or 2 pass difference is a true difference or a false difference. Okay, so let me think. We're going to hold 1 bit constant. Among IJK, we're going to hold 1 bit constant at a time. Then we can scan through every JK for a fixed I, okay? If I scan through every JK for a fixed I, isn't that O of n squared? So that either means that my original performance on no sort was wrong, and they're both O of n squared. Either that's the case, or my original performance analysis was right, and fixing I is the wrong approach. One of those has to be true. So if I don't fix I, what other approach might I take? So I can still scan through the I's. I just can't scan through. The array per I. I can only look at a finite number per I. So what if IJK are always ordered? So let's say I take 2 pointers on the end. That's not going to be helpful unless the thing is sorted. Okay. So I disagree with myself. Now I think that I've convinced myself that no sort is still O n squared. Yeah. Okay, so then let's just not even take this approach at all. I'm going to look forward to double checking the no sort after I do this. So we'll do the sorted approach. Sorting because either approach is going to be O n squared. And if either approach is O n squared, but this one takes less memory, this one is preferred. Okay, so we have nums, and we can just say nums.sorted, I think. Sorted or sort, one of those. Let me just run this to see if this errors. List has no attribute sorted. Did you mean sort? I did, thank you. So I think it's going to be an in-place sort. For n and nums is not sorted. Okay. So let's make with sort instead of sorted, because sorted, sorted is a function that creates a copy. So I guess either way would work. None type is not iterable. -1. So nums is still. Oh, okay, that's nums. That's not standard out. Sorry, I was not even looking at my print. So here's my print. The print is sorted in this case. Good, but is it also sorted in the in-place sort case? Yeah. Okay, so that was already even correct the first time I did it. I was just looking at the wrong print. Okay, so we have nums sorted. What I want to do is fix I, then run toSum on the array without I. Now, do I want to scan the whole array without I, or can I pick a side and pick a, like, so let's say that I is going through the sorted array. Can I just pick one of the sides? That would be better. And the answer will be determined by the target. So if I'm at the far left, so yeah, let's say I go left to right on I. Move left to right on I, fixing I each step. So that means that the overall target is increasing. The overall sum, the triplet sum. This means the triplet sum is increasing. So we can return sad early if the target is below first min pass. Does that make sense? So the lowest the triplet sum will ever be is the sum of 0, 1, and 2. By the way, are we guaranteed to have a 0, 1, and 2? Constraints? Yeah, okay. That would be interesting if they gave me an input that was only like length 0 or length 1. That was a case I didn't think of, so good to double check that. They'll always give us at least 0, 1, and 2 indices. Okay, so the lowest it'll ever be is those three. So if the sum of those three after sort, is above the target, we can return sad early. Do you see the idea? Okay. So if nums 0, I'll just hard code that one. Nums 1, nums 2 is above my target. I don't need to check the equal case because the equal case will be checked in the loop. But the loop is, I think the loop is not going to check the below case. So I'll just do that one here as a guard. Yeah, so if 0, 1, 2 are greater than the target, then we have no way to reduce the sum. So we'll just return sad early. Cool, that makes sense. So here, they're at least equal. So we have two cases to consider, the equal case and the greater case. In the greater case, 1 and 2 will scan up per I, and then I'll increment I. Okay, so the greater case is handled unless it's missed by gap. It could be missed by gap, and that will be this secondary sort of sad case. or if it's missed because I can't escalate high enough. So those are like the three ways that you could have possibly a miss. You could have a super low, a super high, or a gapped miss. So the super low and the super high are naturally handled. Yeah, they're all naturally handled if I write this loop properly. So let's proceed as planned then. For n and nums, let's instead say for I and nums. So cur complement is the opposite of nums I. And why would that be? Because I have my I value and I want to get two other numbers that add with it to 0. So I can immediately determine the complement. Does that make sense? So I have the current complement, and here, now I need to do an inner two sum. How will I loop on this two sum? So I'm going to go make a different function, which is a two sum, like a helper function, and then I'll call it here. And what will that helper return? That helper will return probably like an array, right? Either an empty array, which could be falsy. So the inner two sum didn't find target. If populated, we have a triplet. That's sort of a easy thing to think of. I don't know if it's optimal. Yeah, it's optimal. There's no need to do deduplication because the way I've arranged the slices, they are guaranteed to not overlap. So because they're guaranteed to not overlap, then I can have the inner two sum immediately return the values, not the indices. And that will be optimal because there's no additional lookup needed. You just immediately return the 3 values. Okay. So empty array is falsy, inner two sum didn't find target. If populated, we have a triplet of values. Okay. So two sum result equals two sum of something. And then if two sum result, return nums I will always be the furthest left. Two sum result 0, two sum result 1. I think that's it. I think that's it. So now I just need to make sure that I invoke two sum properly. The target is always 0. That's correct. Okay, so what do I want to pass down here? It definitely needs the current complement. Needs access to the index as well for I and nums. I think that's wrong. While I is less than length nums. I think this is correct. So we'll start with I equals 0, and then down here we will increment I. Okay, so I get my 0. Yep, and that gives me the complement. Great. So I gave it the Kerr complement. I might actually not need to pass that. It's redundant with the index information. But anyway, here's I, and then I want to pass nums. What else do you need? What else do you need, huh? I think that's all you need, twosome. So now I'm in the inner twosome. I'm able to identify my new range. And I can have my new range, and I can have my new target. Yeah, I think that's it. So let's go define twosome. Moose, we love LeetCode. Yes, we do. Thanks for being here. If you're on TikTok, or actually if you're on any platform, give the video a like. On TikTok, you can do a bunch of likes. You can just keep tapping that screen. I guess on YouTube, you can only like it once. Boo, YouTube. So here are the arguments. We have complement. Why is the text in blue? Is it always? Okay, it always is. That's fine. We have complement, outer IDX, I'll call it. And then we have nums. Okay, so left is going to be outer IDX plus 1. Does that make sense? And then right is going to be length of nums minus 1. So we're only looking in that slice to the right of the outer index. Outer might be confusing because you might think like outer boundaries. Really, it's like furthest left. Super left. Let's call it the super left. Does that make more sense? I don't know if that made it confusing or more helpful. We'll call it the super left because it sounds awesome. Okay. Or you could call that left and you could call this middle, but I think super left sounds more awesome. So while left is less than right, and then we just do our twosome that we did previously. And instead of calling this complement, let's call it target. Are we doing LeetCode? Yes, we are, Ryan. What's going on? So there's the Kerr sum is left plus right, but really it's nums left plus nums right. Won't this be n log n plus n squared? Yes, which is asymptotically equivalent to n squared. So the n log n is dominated by the n squared. Does that make sense? Kerr sum nums left plus nums right. And then you have your three conditions. If over, elif under, else found. Oh, why do I return result? I actually don't need that. I can just return immediately. That's better. So return left, right. Let's go ahead and extract, because we're duplicating ourselves. So this will be the left value. It's also a little bit clearer to read, isn't it? Because I've said that it's the right value, and that gives me confidence about my solution, which I said, hey, I want to have the triplet of values. Make sense? Okay. So we have left, right, Kerr sum. Let's use the right value there. Over, under, else match. Great. So if it's over, then I want to move my right hand to the left. And if it's under, let's take my left hand and move it to the right. Plus equals 1. What else is there to say? That feels like the end of the day. Target is not defined. Who wrote this terrible code? Let's see. I think that's what the commenter earlier was saying, was target is always 0. Yeah, I should have just wrote 0. Okay. Anything else to double check? No, I think that was pretty much it. Over is not defined. Oh, I didn't write out that was a pseudocode. Okay, so over, and how do I actually evaluate over? What this means is that current sum is greater than target. And this means that current sum is less than target. Great. Now, -1, 2 is not a valid value for the expected return type, list integer. Did it want a double list? Let's see. Oh, it wants a double list. I wasn't paying attention to the return type. So I gave it a list, but it wants a double list because there's multiple possible solutions. Is that the case? Knowing the target is always 0, it means given I, you know exactly what the value is required to get a 0. Yeah, that's right. That's right. Okay, I think I only accounted for the possibility of a single solution. So here, let's define a results. And instead of returning empty, we will return results. I don't need to enunciate the sad case. It will just be the result if we pass through without appending. So we're going to go ahead and take an append approach. Do the results need to be ordered? I'm not seeing that the results need to be ordered. So I think it's fine to just outright append. Is that the right word? I don't know. We'll find out. Oh, I got accepted. Dope. I guess append was the right word. All right, let's actually run it. Oh, I don't know if I ever ran. Submit. I don't know if I ever submitted my twosome. Okay, so I am returning duplicates somehow. That's bad. Why am I getting a duplicate? Because this is no longer allowed. This is no longer allowed because this presumes a max 1 case. So here, can I just remove it? What happens if I just remove it? If I just remove it, then I'm still starting with I0. I'm still scanning twosome. It's just not exiting early. Asymptotically, it doesn't make a difference. It's just not exiting early. Wait, no, that's still good. That's still a good clause. And it's still going to speed up our average case. So if 0, 1, 2 are above target, there won't be any solutions. That's still true. The inverse doesn't mean there's one solution. It means there could be, the inverse is that there could be many solutions. I think this is possible in n log n plus n. Maybe. That would be cool. Yeah, maybe it could. Let's finish out this solution. So I'm appending multiple results. I need to make sure I don't append duplicates. I could use a set. That would be easy enough. But my question is like, why am I getting duplicates in the first place? If I have 0 on the left twice, that indicates like my I is not incrementing or something. Oh, those are nums 0, 0, 0. Those are not indices 0, 0, 0. Okay, and there's 4 zeros. Wow. Okay, so my eyes were deceiving me. So there's 4 zeros in this failed case. Right. That does. Okay. Okay. So I didn't duplicate on the indices. I duplicated on the values, and that's apparently not allowed. Well, there I go, not reading the description. IJK is such that these are not equivalent. No. The requirement is that IJK are distinct. The requirement is not that their values are distinct. Am I tripping, or did LeetCode get that one wrong? Oh, must, okay. It's here in the words, not in the math. The solution must not contain duplicate triplets. Okay, fine. All right. All right. So it's like a double deduplication. We want to dedupe on the indices and the values. Fine, I'll do a tuple. This feels strange. This feels like I haven't done this before, but that's okay. And so the point of the tuple would be that it's always unique, basically. It's always unique. Given a tuple, the complement is always unique. So let's return this as a tuple. So this is the two-sum tuple result. And if there is a two-sum tuple result, we want to make a result set. Okay. And we will listify it later. This feels like a lot harder than I remember it being. Result set. So I think I'm doing something strange. That's okay. So here's the two-sum result tuple. And if it's there at all, we will add. So result set, with sets, you use the keyword add. Okay. So here we want to add the two-sum tuple result and nums I. You could do that in either order. Let's see. Yeah, maybe it should just be a 3-point. Yeah, it should just be a 3-point tuple. It should just be a 3-point tuple. So let's make this a list again. So that's a list again. And we will add a 3-point tuple. So we still have nums, like basically what we were doing before, except now it's a set. Let's get rid of this word tuple because it's not true anymore. Two-sum result, two-sum result, two-sum result. This will be the 0, and this will be the 1. So pretty much the same thing, but now that we're using a set, it will automatically make the sets unique. Takes exactly 1 argument and 3 were given. I need to force it to a tuple. Cool, that was accepted. Let's run it and submit it. Show your entire screen. I'm not able to on TikTok. You can go to my link in the bio and see the full screen. And in this case, I have a miss. So I said -2, 0, 2. Even fixing I, there's multiple JKs. So let me go to my 2 sum down here. And do similarly. Results is an empty list. We return results. And here we would results.append. Left value, right value. So now this will be a list of lists. So if this is the case, so we have 2 sum results, plural, instead of 2 sum result. And we'll iterate through them and add for each case. Time limit exceeded. Bummer. That's a bummer. Let's go ahead and submit it and see how many we get. So this is 88 out of 313. Yeah, at this point, I think I want to look up the solution. Some of these will time out. That's fine. So it just gives you down to 0. Wow. Show the prompt. Here's the prompt. Take a quick mental look up. Don't look it up. It's easy. In all caps. No, we're time boxing. We're looking it up. Let's see. It showed it on screen a moment ago, didn't it? Is it only when I submit, that's when it gives you the solution? I think so. Oh, this is just what I submitted. This isn't like the actual solution. Yeah, let's look at my own solution. Why not? So there's a couple of these. Here's the standard 2 pointers, and then there's the no sort. So no sort is still O(n) squared. Okay. Good. Yeah, I convinced myself of that earlier. So good to see that my second thought was right. Oh, and I put the list and stuff. I guess it came with that. Set for auto deduplication. Okay, yeah, we learned that we should be doing that. Getting the complement, nums results. Okay, so instead of doing this like if you have a tuple result, I'm just appending it within. That makes a lot of sense. While the current index is less than the length of nums. So just look at all of them. And I was doing while left is less than right. So why would I look at all of them? Because there could be multiple answers. Because there could be multiple answers. So let's come over here. Now that was a no sort, which is like different than what I'm doing here, but let's sets across the board is what I used in my other one. So let's adopt that and see if it helps us. So sets across the board, results.add. Sets will be faster, so that might save our skin. And then instead of while left is less than right, we will say while left is less than length nums, which seems to be too much. That's like over the whole nums. I should only have to look on my slice, I think. Let's try it anyway. Yep. If I tried on my slice, that could give us a speed up. Oh, and this is, okay. This is another trick that's giving a speed up is I do my tuple of 3 within the 2 sum. So I don't return and then iterate through the results. Okay, let's see if that helps us. So here's the results set. And then I don't need to do this at all. Then I come down here, use the results set. And I don't have a distinct results. I'm just using the same results set. Results set.add. Target left val, right val. And the time limit is still exceeded. Let me go back to the left versus right. This is interesting. What is slow in this approach? I'm not getting what is slow here. If I is less than nums, maybe at some point I don't need to even do the 2 sum. Is there a way that I can exit early from that? Sure there is. If the Kerr complement is like less than the max, basically, we can look for a max. That will only give us a linear speed up, but maybe it will help. Max sought or max findable. So here's max findable. If the current complement so if the max findable plus the Kerr complement is still less than 0, there's no way we're going to find a JK. list in int. Let's see. Yeah, it's trying to add lists. That's not what I meant to do. So length here, that'll be an index. We look up the index on nums. That's a value. Oh, my parenthesis is off. That didn't give us enough of a speed up. Okay, so integrating the no sort and the sort together is not helping us. Let's go to the other one. So this is what we were like actually trying to do. Time complexity O(n) squared. Wrap two sum in a single loop. This is like what we're trying to do. If length nums is less than 3, return empty array. I don't think that ever hits though, right? We were given that it's going to be 3. That's fine. So we sort it. We get a result set. We get a wrapper index. This is all making sense. Sort it, result set. Wrapper index is down here. Okay. While the wrapper index is less than the length of nums, that's what we did. The current target is the negative. Yeah, that's what we did. Skip duplicates. This is the speed up I was missing. So how does this bit work? Sort it, iterate through all vowels in two-pointer the index starting at left of vowels index. Yeah, that's what we're doing, right? Two sum is a two-pointer. It's left of vowels index. So that's what we're already doing. It's the skipping duplicates bit that was missing. Yeah, fast forward duplicates. This is what's missing. Good. Good thing we're practicing today. Yeah, so it could be like 0, 0, 0, 0, 1, 1, 1, 1, 1, and I can fast forward those, which I'm not doing. That'll give us a speed up. Okay, so let's look at this other solution and transpose it onto the current approach. So we don't have two sum on the class. We're not passing self, but basically it's the same. Are the arguments the same? I think so. Nums results wrapper target. Nums results wrapper target. Different words, different order, same stuff. Good. It's literally just the skipping part. Great. So let's transpose this over. Definitely a good idea that I looked up the solution after the time box. Otherwise, we'd be spinning our wheels because I was not thinking about skipping duplicates. So, even getting an external two sum results is not needed. It's just appended to the result set. Okay, so how do we do this? While wrapper IDX. Basically, if I move my super left and it's the same value, I can skip all of those. That's what I was not doing. So I'm not using the term wrapper IDX. I'm just using I. While I is less than length nums and the value is we're going to use this Kerr complement as basically a cached value. It's the opposite of Kerr complement, which means it's nums I. Why don't I just put nums I right here? Because we're going to be fast forwarding. That. So I'm not just adding an additional clause. I'm removing the original clause because this statement will always hit at least once. Does that make sense? It will always hit at least once. Okay. That's good. Now I want to do similarly inside of here. So we add, and then while the left value like while I'm allowed to iterate. Okay. So while nums of left plus 1 is equal to the left value. And did I add a colon up here? I did. Okay, cool. So if I increment, it's going to still be the same value. As long as that's true, I want to keep incrementing right now without having to do the additional evaluations. Do you see the steps, the operations I'm able to skip when I do that? Okay. The edge case would be if I go one further and it's like out of bounds. So I can't do that. So while left, but before I do this nums left plus 1, I need to say while left plus 1 is less than length nums. So that's my boundary check. And so while I'm allowed to, and it's a good idea. While I'm allowed to, and it's a good idea, let's skip ahead. While I'm allowed to, and it's a good idea. Here I express this differently. I less than length nums, left plus I. Oh, I wonder if one of those is wrong, eh? It doesn't matter that left plus I is less than length nums. I think is true. I think that's a true statement. I think it doesn't matter because it will get, we will exit based on this condition anyway. So I just need to make sure that left is within the range. I think that's true. Let's see. Max findable. Oh yeah, I don't want to use that logic anymore. Is that going to help us? Maybe I should bring it back and see if it'll be even faster. Time limit is still exceeded. Whoa, really? So let's look at what's different than over here. Left is less than right. Okay, the fast forwarding is different. If left is okay, the fast forwarding is different. Let's see. If left is less than right. If left is less than right. So that's different. Okay, that got us past the timeout, but now we have a wrong answer. -1, -1, 2. Is it because I'm doing the values, the indices versus the values? Yeah. This should be nums left. Nums right. Okay, so that was correct. Did I make a similar mistake up here? So I'm comparing to the length of nums every time instead of left versus right. No, that's correct, because there is no like super right. There's only a super left, not a super right. And let's double check against the prior answer. Yeah, it's the boundary of the array. Okay, so let's submit. We made it. Look, Ma, we made it. Let me bring back the max findable and see if that speeds us up any. Let's submit this 3 times because it kind of bounces around just based on runtime latency. So beats 78.95. We'll run it 3 times. Oh, sorry. 78.95. 76.22. Ooh, that's even faster. So the record is 76. Beats 71. Oh, that's worse. If you beat 71, that's worse, right? Okay, so the best that we got was like beat 78. Oh, and look, there's like a little cluster up there. So there's some kind of optimization I'm missing. Maybe it's the max findable. Let's see. Max findable is going to be this thing. And does it still work? It still works. Let's see if it actually saves us any time, though. And our previous range was all the way from 71 to 78. Now we're at 77, 76, 74. So it's the same range. The boundaries were closer together, so there was less variation, but it's over the same range. So it's not like necessarily better or worse. So I would probably exclude that from my code. It's like complexity that doesn't seem to help much. Okay, that is going to wrap up for today. We got to an answer. Oh, can we do this in nlog n? Let's see. Cannot be solved in nlog n. Binary search was suggested. In my mind, I find that it's easy to implement an algorithm in nlog n. Famous last words, dude. Why people think it's easy, yo. Except it doesn't work at all, right? It's easy. Okay. Well, that's a good counterexample to this, but it's not really a systematic proof that it's not possible. Great. Okay, so the answer is basically like, no, you can't do it in nlog n. Okay, so we got an optimal solution. It took longer than it should. Let's see. Little extraneous logic, missing deduplication, missing fast forward. So basically, like in the initial solution, there was like 3 different flaws. And as well as like swirling on the approach between sort and no sort. But good. So next we'll check in tomorrow or next time we do this, and there will be 4 flaws, like 5 improvements we're looking for. 1, don't get confused on the approach. Like the two sum with wrapper is just better. It's equal performance to no sort and lower memory. Okay. 2, use sets for everything all the time. Just use sets. Get that deduplication. 3, don't forget to fast forward. 4, complete it faster. 5, don't have extraneous logic that looks like it's going to save you time in some cases, but then it really doesn't though. Great.